In previous videos, we were addressing linear equations, whether they were linear equations with strictly an equals or whether they were inequalities. There were certain characteristics that they had. There were no visible powers on the exponents. We might have something like 2x plus 3 is equal to 4, and though this x is understood to be x to the first power because it's only there one time, it's not like x squared, x cubed, x to the fourth. And so what we did is we had a set of rules, a set of steps to follow. And what we would do is simplify the left side, simplify the right side, get your variables on one side, get your constants on the other side, and solve for x. And then there were variations, what if it was an inequality, and so forth. And so this is our list of steps for linear. Now what we're going to start covering today is what if it's not linear. And we're going to start off with the basics, which the very basic one is what's called a quadratic. And the highest power that you would see in there is a square. All right. So the idea about a quadratic equation is that it's of this form: ax squared plus bx plus c equals to 0. So this could be something like 2x squared plus 3x plus 4 is equal to 0. And in this case, a would be 2. A is the number that multiplies the x squared. B would be 3. That's the number that multiplies x. And c would be 4. All right. So the main thing here is if it's got a square right there, it's quadratic. All right. It could be missing this 3x term and just be 2x squared plus 4, and it would be still considered quadratic, right? And it could even be 2x squared is equal to 0, and it would still be a quadratic because it's got an x squared, though that becomes kind of like a trivial problem, but you get my drift. All right. Now, so what we do here is substantially different than what we're doing over here with linear because these are going to be nonlinear equations. So if we have nonlinear, it's going to be a different set of rules. And what I want to do is to demonstrate for you what we're going to do, and then we'll kind of draft up maybe some steps for it, and then I will type those up just like this, and then you can compare them. All right. So the concept here is we don't want our constants on one side and our numbers on the other to where we would then solve for x like this. We want it equal to 0 if it isn't already. All right. So now there's one case where we don't want that, and we'll get to that in another video or two. But 95% of the time, okay, we want it equal to 0. And then once we get it equal to 0, the first type we're going to look at is maybe we could factor it. All right. And if we factor it, it is based on the principle that if you have something a times b, let's use different letters. So if you have something like f times g is equal to 0, all right, then if that's true, doesn't it make sense that one of those at least has to be 0? I mean, 0 times anything is 0. 0 times 0 is 0 as well. So either f is 0 or g is 0, or they're both 0. And this is called the principle of zero products. All right. So if two things multiply together to get you 0, one of them or both, okay, could be 0. So it goes kind of like this. Now we're going to practice some things that are going to come up later, right? So for factoring, it doesn't matter that you can identify what A is and B is and C is for most of the factoring kind. There is one style of factoring that asks you what A and C are. But let's practice because it's going to be important when we get into the quadratic formula, right? So in this case, A is an understood 1 because there's ununderstood 1 multiplying the x squared. B would be 0 because there's no x term, and C would be a negative 4. Now, that's just so that we can get used to figuring out what A, B, and C are. To factor, you would look at this and remember your factoring strategies from your previous coursework. And so there's a whole bunch of different styles. You know, is there anything in common to factor out? Is it a trinomial with a lead coefficient of a 1? Is it the difference or sum of two squares, the difference or sum of two cubes? Factoring by grouping, and then that A times C method. So this one falls in the difference of two squares because x is squared and 4 is a square. So when you factored the difference of two squares before, you had two binomials. The two x's in the front give you x squared when you multiply them out. And if you squared 4, you must have squared, I'm sorry, if 4 is a square, you must have squared 2. All right, so then this would be 2, and this would be 2, and one of them's plus and one of them's minus. And some of you may say it's x minus 2 times x plus 2, and that is the same thing. It's like saying 2 times 3 is equal to 3 times 2. Well, x minus 2 times x plus 2 is the same thing as x plus 2 times x minus 2. It's all good. Now, that principle, that zero product principle, right, says if these two things multiply together to get you 0, either this one is 0 or this one is 0. Well, you know, maybe they both can be, right? So x is minus 2 or x is 2 after you shift it over. Now I want you to see a couple of little things that I think are kind of interesting, right? This highest power that you see right up here, the highest power that you see on a polynomial is called the degree. And there's all sorts of interesting things about the degree that we'll be looking at as we go through this course. But the first thing we're going to talk about is the degree tells you how many answers you should expect. Now, you don't always get them. That's kind of something that's kind of like a teaser for the future, okay? But you're expecting two answers, okay? Because the degree says, I'm looking for two answers, two solutions to this, all right? Now, when you factor this, did you notice how the two factors just had an understood power of 1? And so these two factors became, right here, they became two linear equations. Okay, so when you break down this quadratic by factoring, you're breaking it into 2, which is related to this 2. You're breaking it down into two linears. So once you get it to this form, you're going to switch your list and switch over to this list right here. So you're going to start on your nonlinear list and then switch to linear after you break it down when you're factoring, right? Now, we could try this and you're going, how can it be 2 and minus 2 at the same time? It's not, okay? But let's check. If x is minus 2, all right? And what we're going to check it, I'm going to check it in kind of into both places so that you can see what's going on. First off, if you check it into x squared minus 4, which is what you're supposed to do to make sure your work is correct, you would have negative 2 squared minus 4, is that equal to 0? Now, a negative squared is positive, so negative 2 squared is 4, minus 4 is 0. Yeah, that's true. Okay, that's a good one. Now, let's check it into this x plus 2, x minus 2 is equal to 0, because you're going, I don't see that one, all right? So if x is minus 2, you would have minus 2 plus 2, minus 2 minus 2, correct? So minus 2 plus 2 is 0, and this is minus 4. So see, you check one at a time. So this one's going to be 0, and this one is not 0. But 0 times anything is 0, so we're good. All right, what if we checked x is 2? If we check it into the original, we would have 2 squared minus 4, is that 0? And yes, 4 minus 4 is 0. Yep. Okay, if we check it into this x plus 2, x minus 2, equals 0, you would have 2 plus 2, 2 minus 2, and this would be 4 times 0, and so this would be 0, right? So see, when you do that, here, this one turns out to be the 0, and this one's not. So when you plug them in, you plug them in individually, and one of them is 0 and the other one's not. But these are your two answers. Okay? All right. Now, I'm going to leave it up to you to check most of these now that you understand the principle of checking is something that you can do to correct your own self before the teacher does it for you. And we're going to stick with factoring so that we can review our factoring. And I'm going to make some factoring videos to remind you of the different types and put those in the description. There'll be links to those videos. Okay? But let's see how much you can remember right now. Okay? So you would look at this and go, well, okay, there's nothing in common to factor out. It is a lead coefficient of a 1 with a trinomial. So we would say, well, I have an x there and an x here to get my x squared, because x times x is x squared. And you would ask yourself, what multiplies to 8, positive 8, and adds to 6? Well, 1 and 8, 2 and 4. Okay? So which pair multiplies to a positive 8, so they're the same sign, and adds to a positive 6? How about 2 and 4? So 2 and 4, both being positive, would multiply to 8 and add to 6. If it had been x squared, minus 6x plus 8, you would have said, here's an x, here's an x. What multiplies to positive 8 and adds to negative 6? They would have to both be negative. And those would multiply, right? Negative 2 times negative 4 is positive 8 and adds to negative 6. All right, back over to here. Because remember, the degree is 2. So I'm expecting 2 answers, 2 factors. All right. So if these two multiply to 0, either x plus 2 is equal to 0 or x plus 4 is equal to 0. So x is negative 2 or x is negative 4. All right. And you could check those, right? Let's just look at the 2, right? And let's just try it in our kind of jotting it down above. Negative 2 squared is 4. Okay, negative 2 times 6 is negative 12 plus 8. Yeah, that's 0. Okay, and you can check each one as you go. Now, your teacher may want you to say x is negative 2 and 4. The computer may have you do it a particular way if you're doing computer homework. You know, I tease people all the time, and I tease my students, and it's actually true, but it sounds kind of mean, okay, which is the person or thing with the red pen wins, okay? So if I'm demonstrating it by putting x is equal to minus 2 and x is equal to negative 4 separately, and they're putting them together, you do what the person who's grading your work wants. I mean, that's the nice way to put it. Okay, but let's boil it down and kind of have a smile about it, I guess, is the one with the red pen wins. All right, whatever format they want it in, if it's legal, all right, that's the way it's going to be. Now, we don't always have to work with x's. Let's try a t. So this is 3t. I'm going to put a cube right here. 3t cubed plus 2t is equal to 5t squared. Okay, now if it's got powers on it and you're trying to solve it, okay, for all but one case, you want it equal to 0 because this is not linear. Okay, so this seems to be something we can put on our list. It seems like we're doing that all the time. So if it's nonlinear, okay, the first thing we want to do is we want to make it equal to 0. And your list can be just that fast. It has to be equal to 0, right? Now, once you get it equal to 0, all right, you're going to pick several different methods to solve it. And right now we're solving it with factoring. Right? So how do we factor? We review our factoring techniques and try to pick the appropriate one. All right, so this is not equal to 0. This is equal to 5t squared. So we're going to move the 5t squared back to the left. And since it's a positive 5t squared, we're going to subtract it. So we'd have 3t cubed minus 5t squared plus 2t is equal to 0. Now it's considered standard form, proper form, not going to have partial credit taken off form. Okay, when the powers descend. So we have 3, 2, and understood 1 power. So this is considered proper form. All right. Now we would look at this and go, oh, look, everybody's got a t. All right. So there's a t in common. So one of the first things you looked for factoring was, is there anything in common to factor out? Sure, there's a t. Okay, so let's take out the t. That would leave me 3t squared minus 5t plus 2 equals 0. And you would say, well, I've got the t, but the 3t squared minus 5t plus 2, it doesn't have anything in common to factor out anymore. It's not a lead coefficient of a 1, where you say what multiplies to the end and adds to the middle. It's not the difference or sum of 2 squares or 2 cubes. This is the one where, depending on who you have and what book you're using, it could be the trial and error method. That's the way it primarily was taught, um, I'd probably say up till about 20 years ago. It was the trial and error method, which I enjoy, okay, because that's the way I learned it, and I think it's kind of fun. It's like a puzzle, but the title says it all. You try it, and you're wrong. Okay, so the trial and error method is try it, and you're probably wrong. So keep trying it until you're right. Okay, that's literally what it means. And then after a while, people came up with all sorts of different methods. I've heard stuff called the magic method. No, okay, I'm not going to explain that one. Anyway, so to be honest, I have teachers that used to work for me that did it all the time, and every semester I'd ask them to explain it to me, and every time they'd show it to me, and I would just look at it and go, I can't do it because I don't get it. I don't understand how it works. It truly is magic. So I'm going to show you a different technique. All right, and it's called a lot of different stuff: front times the back, A times C. The alternative to the trial and error method, who knows what it's called in your class or your book. All right, so we're going to hold on to that thought that there's a t over here. All right, and we are going to just focus on the fact that we have 3t squared minus 5t plus 2, and we're going to factor it. All right, now a is 3 and c is 2. Right, so what we're going to do is go, what is a times c? Well, that would be 3 times 2, which is 6. So do you remember up here where we said what multiplies to 8 and adds to 6? Remember that one? Okay, this is a variation on that. What this is what multiplies to 6 and adds to negative 5. Right, so we're going to say what multiplies here, not to 2. But we're still adding to this middle term. So what multiplies to 6? 1 and 6, 2 and 3. Now it multiplies to a positive 6, so they're like signs. So it's either both negative or both positive, because it multiplies to 6, because 3 times 2, this is plus 3, plus 2. All right, what multiplies to 6 and adds to a negative 5? What do you think? Well, 1 and 6 would add to 5 if they were different signs, but they're the same sign, so they would either add to positive 7 or negative 7. This negative 2 and 3 right here would multiply to a positive 6. and would add to a -5, so I think that's it. This method works so well that you are going to get two factors, and they may be the wrong ones, okay, but you're going to get two factors. It's not like it stalls out if you're wrong. So spend some time over here in this section trying to figure out what two numbers you want to use, because if you pick the wrong two numbers, you'll get two factors. They're just the wrong ones, all right? When you go and look at the videos on how to do these, I'll demonstrate some things for you. All right, so I'm thinking it's those two, and here's what you're going to do. You're going to stretch this trinomial out like it's a rubber band, and then you're going to take these numbers right here and this variable right here, and you're going to duplicate those, carry them over, set them down in the gap, right? So we're going to have -2t minus 3t. All right, I'm going to make that a little bigger so it fits up. Minus 3t. All right. Now, let's double check. All right. Does -2 times -3 multiply to 6? Yes. Does it add to -5? Yes. Okay, I think I'm good. And this is four terms, and yes, the two middle terms together would combine normally and would give you this -5t, but we're trying to factor, so just hold on to this thought. And what we're going to do is we're going to factor by grouping. So we're going to group this front two and this back two. All right. So what's in common in the front two is, if that's all you had to look at, don't look at the back two, just look at the front two. What's in common in the front two? Just a t. So that would leave you 3t minus 2, correct? What's in common in the back two? Nothing. Okay. But when there's nothing in common, there's always a 1 in common, and you have to factor something out, or even if it's just a 1. So I'm going to factor out a 1, and you're going to pull this negative sign right there. So I'm going to factor out a -1. So -3t dividing out a -1 is 3t. And +2 dividing out a -1 is -2. So I'm not sure, let's check this. Because whatever you do to get this line, you should be able to back up and get that line up there. I have known since I was probably 10 that if there's a negative to be dropped, I'm going to be the one that drops it. So every time I do a line, I'll look back up and go, wait a minute, did I lose anything? And what I'm doing is going, okay, does -1 times 3t get me this -3t right here? Yes, it does. Does -1 times -2 get me this +2 right there? Yes, it does. All right, so I think I did that correctly. Now we look at these two terms, because here's a term and there's a term with this minus in between, and go, oh my goodness, there's a 3t minus 2 in common. So we factor out this 3t minus 2. And when you factor it out of this term right here, that leaves you a t. And when you factor it out of this term right here, it leaves you the -1. Can you see it? All right. Now, if you're sitting there going, I don't know about that, let's multiply this out. 3t times t is 3t squared. 3t times -1 is -3t. -2 minus 2t minus 2 times -2 is +2. So sure enough, 3t squared minus 5t plus 2. See? So you should be able to check all of your work before you turn it in. So what I know is that this factors down to 3t minus 2 times t minus 1. And that principle about multiplying things together to get 0 works even if you have 3 or more things. So if these 3 things multiply together to get you 0, either t is 0 or 3t minus 2, I keep wanting to leave that minus off. See, I told you I could drop it, is 0, or t minus 1 is 0. That's supposed to be an or. All right, so t is 0 is already done. 1 down. All right, 3t is equal to 2. Divide both sides by 3. T is 2/3. And t would be equal to 1. And you see how the degree was 3? So I expected 3 factors, which I got. And these 3 factors, each one's linear. So we got our t's on one side, constants on the other, solve for 1t. T on one side, constant on the other, right? So we switched over to our linear rules. All right. Let's do another. What if you have x squared minus 6x plus 9? Now, this one actually fits 2 types, all right? But I'd say when I'm grading, most students see this as it's a lead coefficient of a 1 and a trinomial. So what multiplies to 9 and adds to 6? What multiplies to 9? 1 and 9, 3 and 3. Okay, so what multiplies to a positive 9 and adds to a negative 6? So you have an x here and an x here. How about negative 3 and negative 3? Don't those multiply to a positive 9, add to a negative 6? So either x minus 3 is 0, or this x minus 3 is 0. So x is 3. I got the same number twice, right? So my answer is just 3, because we don't want to repeat it. We'll find out later when we get around to graphing that this is considered a double root, right? And that it has to do with the x-intercepts. When we get to graphing, you'll see that each one of these we've been finding is an x-intercept. And this one would be called a double root because it's there twice. Now, another way to write this one is to say it's x minus 3 times x minus 3 is x minus 3 squared. So this would be a binomial. This is 2 terms. It's a binomial square. And that is its own kind of factoring. And we're going to use it in the next video when we're talking about the format where you square root both sides and completing the square, right? So let's look at this one. 64x cubed minus 27 is equal to 0. This one is the difference of 2 cubes. 64 is a cube, x cubed is obviously a cube, 27 is a cube. So this is the difference, because it's a minus sign, the difference of 2 cubes. There's also the sum of 2 cubes. So how do I factor it? I say, show me the cubes. 4x cubed would be 64x cubed. So I want to see what you cubed to get this. Minus, and I would have cubed a 3 to get 27. All right. Now to factor this, you show the cubes. You literally break it down and show what you cubed. Then you drop off the cubes. Write it down as a binomial, and then you're going to write this really long trinomial. And it goes like this. You take the term in the front, that would be 4x, and you square it. Okay, 4x squared would be 16x squared. You take the term in the back, that'd be 3, and you square it. And you put it in the back. You take front times the back. Don't worry about that minus sign. You take the front times the back. 4x times 3 is 12x. And now we're going to take care of our signs. If this is a minus, this is a plus. These two alternate. This one is always plus. And there will be a video on how to factor the sum and difference of 2 cubes. Now, we're going to leave this one here for this point in time. I just wanted to show it to you so it'd be, kind of fitting in with the factoring stage, but we're going to actually come back to this concept because this trinomial right here, if you don't have anything in common to factor out, this trinomial does not factor. Okay, if it factors, something went wrong with what you did up above. Okay, so, or you have something in common to factor out, but it doesn't factor as in what multiplies to this and adds to that. So you would have to run that through the quadratic formula, which we don't know yet, right? So I'm just going to leave this one sitting here. We'll come back to it, when we get there. Let's look at this one. 81x squared is equal to 49. Now, this one has a power on it, right? So it's not linear, it's nonlinear. So we need it equal to 0. That's the first thing. You're going to find out there's another way to solve this one later, right? And so you would go, oh, this is the difference of two squares, right? This is that conjugate thing again. So what did you square to get 81x squared? You squared 9x, and that goes in the front. And what did you square to get 49? 7. So 7 and 7. And the idea that these are conjugates, and it's spelled like this, is that the two binomials match. So far they match, right? You have a 9x and 9x, 7 and 7, and one's plus and one's minus, or the other way around. So either 9x plus 7 is equal to 0, or 9x minus 7 is equal to 0. So 9x is equal to minus 7. 9x is equal to positive 7. Divide both sides by 9 because we're working these separately. Negative 7/9. X is positive 7/9. And you may see people write it as plus or minus 7/9. This is sort of the shorthand way to do a positive and negative version of numbers. Or they may want you to write it out clearly as two factors. All right? All right. Last one. 2x squared minus 6x minus 8 is equal to 0. And you would go, well, is there anything in common to factor out? Yes, a 2. X squared minus 3x minus 4. All right, 2. And I'm going to break this down into two binomials, right? Because it's a lead coefficient of a 1, I ask myself what multiplies to negative 4. Okay, 1 and 4, 2 and 2. What multiplies to negative 4, so they're different signs, right? And adds to negative 3, so the bigger number's negative because you have more negatives left when you add. So negative plus, and well, these are the same size. So plus 1 and negative 4 multiply to negative 4. And plus 1 and negative 4 add to negative 3. So we would have x plus 1, x minus 4. So we're going to work right to left for just a second. So either x minus 4 is 0, or x plus 1 is 0. And if you do this and go, or 2 is 0, and you go, wait a minute, 2 can't be 0, okay? So this is not going to come into play because it would be the same thing as if you said, for some reason, I have x squared minus 3x minus 4, this part right here, okay? Would it be legal to multiply the left-hand side by 2? Sure, as long as you multiply the right-hand side by 2. So you'd have 2x squared minus 6x minus 8 is equal to 0, which is where we started. So in effect, it's like when they built this, and this is probably actually how it happened, they came up with this x squared minus 3x minus 4, and they multiplied it by 2 because when it's equal to 0, the 2 on the other side doesn't show up because 0 times anything is 0. All right. So x is minus 1 and x is 4. So these are my two answers. All right. And I hope you're doing okay with this. Now I'm going to be creating the factoring videos, okay? And they will start showing up in the links in the description. And also remember there'll be practice problems for you to do this one. Please like or subscribe. And the next video, that's not a helper video, that's not the factoring reminders, is going to move on with what do we do with these nonlinears, okay? So when we come back, I want to kind of talk about lists, but let's go up here for a second. So what do you know about factoring? Well, let's start off at the beginning. If it's nonlinear, we don't want our variables on one side, numbers on the other, we want it equal to 0. If we're going to choose to factor, because there's other techniques we could pick from, if we're going to choose to factor, we're going to have to run through another list that says, okay, if it looks like this, it does this. If it looks like this, I do this. If it looks like this, it does that. I've actually got a handwritten list of what the rules are and an example with each one, and I will also link that in the description, okay, so that you can see all the rules all together, well, in the order that I would normally teach it, and so they will all be there, and that's in the description as well. All right, see you at the next video.